So the reason I'm interrupting your work time with this is because something weird happened. So this is assignment 21.5, which you're seeing for the first time. And this is just problem number one. What I'm about to zip it. What I'm about to show you on problem one will happen also on problem two. And so if your back is turned to me right now, just rest assured I'm not going to go through this with you again. What happens, well, first off, I have to copy the problem. So I have two, negative two. You can do this along with me because you have to do this problem anyway. Um, so we'll all kind of do this together. I know you don't generally enjoy these problems very much, and you do have my sympathy. It's not like I was pretty open about this the day we started row reduction. I don't find this to be enjoyable or relaxing in any way. I like elimination, not so much this. All right, so here's what I wanted to show you is that we're going to set out and just approach this like any other problem. And our goal is going to be to use this 2 as a worker bee. This will be a very short video, by the way, unless you want me to finish the problem after I show, because I don't mind at all. Um, as you know, because you've done some of these now, is we're going to use purple to kill yellow, right? And so we're going to define a row operation. And what's it going to be? Perfect. So it's going to be row one plus double row two. So with row one being the worker bee row, I'm going to copy that row over to negative two, one, and then nine. And this is where it happens. It happens right away. So I'm going to double the middle, add the top. I like to do my multiplier first, given the choice. So I'm going to double the middle and add the top. So the yellow and purple is obvious. Double the yellow plus the purple makes what we knew would happen, 0. What we didn't intend to happen is what's about to happen. And it is a problem, but we can fix it. So if I move across to the second column, if I double the middle and I add the top, what's double the middle is 2. Add the top, 0. That's a problem. These diagonal elements right here where I'm drawing a red line need to not be zeros. Okay. Uh, it, I mean, part of me thinks this isn't even an appropriate situation in which to do row reduction, but if we're going to do it, let's do it. So we're going to fix this in a moment, okay, and I'll show you how. But let's finish this red row operation first. So remember, we're going to keep doing this. Double the middle, add the top. So if you double the middle, negative 4, add the top, negative 4 plus 1 is negative 3. Keep going. Double the middle, add the top. Double the middle is negative 6. Add the top. Negative 6 plus 9 is, of course, positive 3. So let's keep going, and then I'll show you how to fix this situation that we've found ourselves in. So remember, we change our focus now, and our target goes from being the negative 1 now to the negative 3. So how are we going to pair up purple and yellow to kill yellow? Good. And I'm just going to do it in a different order, not to be rude, but I'm going to do 3 R1s plus 2 R3s. That math should be simple for you. You've seen it so many times now. To murder a 3 and a negative 2 or a 2 and a negative 3, just change them both kind of behind the scenes into 6, right? 6, negative 6, whatever. And then add them together. So triple the top is 6. Double the bottom is negative 6. Surprise, surprise, we get a 0. So again, stay strong here. Triple the top, negative 6. Double the bottom, 4. Negative 6 and 4 make negative 2. Triple the top, double the bottom. Triple the top is 3. Double the bottom is negative 4. 3 and negative 4 make negative 1. Triple the top is 27. Double the bottom is negative 22. Add them together, you get 5. So this is where the lecture can either end and I can let you work, or again, after what I show you now, we can finish if you'd like and get one of the problems done together. Your call. But this change is a simple one, and it's just a real basic row operation. Every one of these rows is an equation, you know that. And equations don't have to be, they're not married to their locations. I couldn't take a part of one equation and put it somewhere else. But what I could do is I could physically pick up one of them and move it. So having said that, there's absolutely nothing stopping me from taking these two rows right here and switching their positions. Let me ask you a question before we do this real quick. And if you can answer this, I'm super excited for you. I could also solve my problem by switching these two rows, but why would that be bad? Think about this. Because this zero right here, I'm going to highlight it in yellow for you. This zero, which we made, would now be lost. Do you agree? So it's not just willy-nilly. We're not just picking two rows at random. I'm picking two rows to swap that will accomplish two things. Number one, I will get a non-zero into the center, which is what I want, and I will preserve those two zeros. These two yellow zeros are not to be ruined. Why would we do that? So if we take rows 2 and 3 and we just simply change their positions, we solve our problem. So as far as showing work is concerned, you wouldn't have to show me anything in a case like this other than maybe a little two-headed arrow like that. That would be your communication to say, hey, I'm just switching a couple things here. So before we do our next math operation, we're just going to do a little bit of annoying relocation. Top row just watches all this happen. Who's my new middle row? Nice job. So that entire bottom row picked itself up and took the place of the second row. Completely legal. There's no witchcraft involved here at all. And then the top or the middle row then goes to the bottom and everybody's happy. So the middle row, the artist formerly known as row 2 is now row 3. So he is now down here, 0, 0, -3, 3. So what we did is we preserved our zeros and we fixed our problem of not having a good number in the middle. Yeah, man.
So does that still mean that the middle row equals B?
But
Does the middle row still equal Z or does it equal Y?
anything in this column is always an X. Anything in this column is always a Y. Anything in the third column is always a Z. That doesn't change. Like this equation, even when it was down here, said 0X's minus 2Y's minus 1Z equals 5, right? Just because I put it someplace else doesn't change what it says. It just is somewhere else. Make sense? Would you like to carry on and finish this together, or would you like me just to shut up and get out of the way? You pick. Yeah, Parker.
Oh, no.
You guys want to keep going? Anybody care? You don't care? Do you want me to shut up? Yeah. Okay. England wants me to be done. No harm. I'm not. Were we done or are we finishing? This is awkward.
Yeah. I think
What's
I
that?
might try it and then it does help.
Since we've come this far? All right, let's finish. What's nice, since none of you had any input, thank you, Mrs. Wiles, for actually having some. What's nice is we got a 0 already right here. So that is a nice bonus that we get from doing a row swap, is that a 0 that we were trying to eliminate actually goes somewhere where we want them to be anyways. So this next row operation, this next matrix change is only going to involve one thing. Who's the only number that we have to kill? -2. And who's our worker? -2. So again, I'm going to try to be always as consistent as I can. You know this about me I find a color and I just stick with it, right? So purple's going to kill yellow. This should be a pretty straightforward row operation. What's it going to be? And I'm just going to do it the other way because I like to use my worker as so sorry. I'm going to take the opposite of the middle. So opposite of row 2 and then add unmodified row 1. Again, third row gets to sit this one out because his 0 is already where we want it to be. This step normally would involve making top and bottom zeros, but we don't have to worry about it. So this time, before we begin mathing, we're going to copy over 2 rows. We're going to copy the bottom, and we're going to copy the worker B, And then all we have to do is follow our rule that we wrote to make the top have a zero where we want it to be. It's a basic operation, so just keep reciting it to yourself, opposite middle plus top. Or if you want to do what Morgan said, opposite top plus middle, or work just fine too. If you do opposite top plus middle, you'll get different answers than me, but not in a harmful way. So I'll show you what I mean in a second. But if we do opposite middle plus the top, we get 0 plus 2, we get 2 plus -2, we get 1 plus 1, and we get -5 plus 9. Got it? If you had done what Morgan said, your top row would be every number would be the opposite of mine. And that's one thing that I'm always aware of when I grade your tests. So the way I grade your tests is I go through all of my work and your work, and I just comparison one matrix at a time. And it would be perfectly normal if I were grading right now to see this as a negative, and a negative. I would still green light this student and say, we're on to the next step. Okay. It's not a big deal. You might think that that's weird, but it's not. It just means that that row is multiplied by -1, which we know is no big deal. All right, I do see a little shortcut. I got to be honest, I'm not sure if it's worth the time. These are such little piddly numbers. Y'all see it, right? That the top row could be divided by 2.
Bottom by 3 probably.
Right. And so, I mean, if you want to, let's make this the best version of itself that it could be. Let's take the bottom row and divide it by -3. Because if we're going to do it, let's do it the best way we can. And that is to turn this one I'm circling into a 1. I think that's always the best course if we're going to do it. I just feel like, again, with numbers this small, we're not going to hurt anything, but let's do it. And then the top row, it makes more sense to me to divide it not by 2, but by -2. And that way there, we're going to get a real sweet collection of numbers that will just virtually auto eliminate. So if you're going to do it, make it as, do it the best you can. So I'm going to take the middle row and just copy it because I'm not changing him. Oh, I can't. Well, I could. I could divide by like a negative, but that'd be really weird. What's my new bottom row going to be? Nice job. And how about my top row? Yeah, except I did divide by a negative, so I'm going to go ahead and do that just because I'd rather have that negative. The number I'm pointing out with an arrow, all things, if I'm going to do it, I'd rather that be a -1. It's going to be a little less stressful. So if I divide by -2, they become -1, 0, -1, and -2. Listen, you can't ask for a more delicious row of numbers than those numbers in the green or column. The green box is the most delicious setup you could ever ask for. There's nothing sweeter when you're about to eliminate a column than to see a 1 and 2 -1s. Like and we made that happen. So that's pretty cool. So that's it. We're basically done. So now we just have to copy over the bottom row because it's done. 0, 0, 1, -1. And then what is my row operation for the row 2 here? Super clean. Yeah. So my worker B is the purple one. So I'm just going to do R3 plus R2, work my way out. And what's my row operation for the top? Yeah. Again, I like to do my worker B first when given the choice. So I'm going to do R3 plus R1. It just feels more solid to me to start with my worker B when I can. This will do it. And I didn't mean to write row 3 plus row 1. I meant to write row 3 plus row 2. My bad. So hopefully you caught that there. All right, let's do this. So row bottom plus middle is a good plain way to say this. Bottom plus middle is 0. Bottom plus middle is -2. Bottom plus middle is 0. Bottom plus middle is 4. And then we're on to the top row. And again, simple, recite it to yourself. Bottom plus top this time. Bottom plus top, -1. Bottom plus top, 0. Bottom plus top, 0. Bottom plus top, -3. So once you survive that step where you swap the rows, you'll find assignment 21.5, as I intended originally, to be much more simple, like way more simple, because I asked the computer to use smaller numbers. So normally what I ask it to do is keep the numbers at 5 and below. And this time I set it at 3 and below. And it makes a monumental difference in the difficulty. So this top row states that the negative of x is equal to the negative of 3, which implies then that x must equal 3. Done. The second row states that negative 2y's must equal positive 4. What's y? Right. And then this third row states, well, it's done. It just states that z equals negative 1. Right. So our final answer is 3, negative 2, negative 1. Got it? All right, I'll pause this, but I'll keep it alive so that if there's others, I don't want to take up any more of your time. I've taken up enough. If there's any more that you want to talk about, you can always bring me your paper. I will post my answer keys online. They'll help you. If you want to try to find your own mistakes, which is fun, you can mirror your work to mine. We should be doing the same things. Our matrices should, that's the one thing that gets me through this, is that my matrices and your matrices should be virtually identical. So if you're looking for a boo-boo, if something goes wrong, you can look them up yourself, or I can look at them for you. It's up to you. Got it? All right, rad. Carry on.